Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video we're going to look at a delivery I received this week, and it was from JLC PCB, and these are the updated version of the Robo Hat. So I ordered 5 boards. JLC PCB allows for a minimum order of 5, so for a prototype that's ideal. And they come in a box with a bit more bubble wrap and packaged and heat sealed into what looks like bubble wrap. So let's open this up and have a look at our boards. It's a little bit of desiccant in the sealed in with it to keep it all dry. Now that's interesting. So this is my version 2.2. So my next attempt, I actually made 2 changes between ordering. So the first change I made to the boards was to correct an issue with the addressing. So on the pins on this chip, there are 2 pins up here which are used for addressing, and I had swapped them around inadvertently, which meant the addressing wasn't as expected. It also meant that 2 chips over here were going to be on the same addresses as 2 of the chips on this board, which was not going to work for us. So I had to fix that problem. The other change I made is I added an extra pair of pins here. So now, and if I flip this over, we have 2 grounds and we have 5 volt and 3.3 volt. Now on the original design I only had 1 ground and the 5 volt. I added the 3.3 volt because the I2S is all 3.3 volt based. So the I2C, that is the SCL, the SDA, ground and 5 volt, because on this side of the board I actually have transistors and resistors here set up to do a level shift, but the I2S didn't have the 3.3 volt available. So now that's done, and when I upgraded my PC recently, the one I use for video editing as well, I reinstalled or installed a new version of KiCad, and the major difference is now it's a little bit clearer down here where pin 1 is. So if you remember one of my previous videos, once I put the solder paste on, it was not clear which was pin 1. So in this case pin 1s are here. I ended up putting a number of chips on backwards, which resulted in failure of a couple of chips and things just generally not working. So hopefully we don't have that problem again. Now part of that was I was putting on way too much solder paste, and to help with that I ordered this. So this is a stencil from JLC PCB for this board. So let's open that up and have a look. Okay, so looks like they've got a bit of used backing board, lots of little drill marks in there, and this is noted to be the Raspberry Pi Robo Hat version 2.2. It's hard to see on that. That's better. If I open this up, and what we have is the stencil. It looks like they've got some tape over the top of that. This has got drill marks all over the back of this as well. And it's held down to, it's not very thick, is it? it's held down to the backing board. So it's been shipped so it won't get bent. So it's got tape on both sides. It's, as you can see, it's fairly flexible. So let's see if I can get this tape off carefully. That side came off all right. Okay, so in this corner, it does say model Raspberry Pi RoboHat version 2.2. It's got the size of the board, that's 28 by 38 centimeters. The date, so this was ordered 27th of the 12th, 2024 at 10 p.m. and must be their internal production number. The thickness of this, I'm guessing, so the size will be 28 by 38 centimeters. So that's the overall size of the stencil, and it's 0.1 millimeter thick, which is more than thick enough for the solder paste. I did have way too much solder paste on when I was trying to do the last one. Okay, so in theory, if I put this board underneath, I should be able to line this up with the traces underneath. And that's pretty lined up at this end anyway. And I probably need to align it a bit better at the other end. But to do that, I think what I need is a smoother surface. So I'm just going to put all this to one side. So it definitely goes that way. And I think if I tape down to my desk a number of these boards, I should be able to then move this around quite easily. And that looks pretty good. I might just fire up the microscope so you can actually see better as to what I'm actually doing. Alright, so I had some issues with the microscope, so I've gone back to my overhead camera. For some reason the microscope decided that it was not going to be helping me out much. So you can see here the pads underneath through the holes, and this is actually quite ideal. So looking at a couple of places, you can see the pads are pretty much aligned. More importantly, those pads are aligned. That's one of the smallest chips on the board. There's another one over here. And that's not too bad either. So What I'll do now is I've got to apply, I should stick that down so it won't move. So I'm just going to grab some tape. I have some masking tape at hand. Now here I have some solder paste. This is the 180 degree melt solder paste. I do have some other solder paste which has arrived, which is 138 degree melt. And I might actually try this out. And I'm going to need a squeegee of some sort, which is something I should have thought about before I started recording. And this card will do the job for what I need. So we're just going to put a little bit of solder paste on. And I think that looks pretty good. So our next trick, that out of the way, is to carefully lift up the mask. That's where masking tape comes in quite well. And pull out the board. So if we have a look at that under the microscope now, and you can see there's solder paste on all those resistors. I've probably still got a little bit too much on those resistors. It's probably because I didn't have it flat enough in the middle. But it's nowhere near as much solder paste as I had on when I was doing the first attempt. So the next trick is going to be to put all of the components onto that board. So I'm just going to clear my desk up a little bit before I attempt that. So I'm just going to pause the video and come back as soon as I've got my desk cleaned up a bit more. Okay, so now that we've got the solder paste on the board, and it doesn't look too bad, it's a lot better than my first attempt doing it by hand. I think we'll start putting some components on the board. So I've got my tweezers out, and we'll start putting some resistors on. Now I just recently received some 68 ohm resistors. One of the resistors over here are 4. Let me move this so you can see it. So R4 all the way down here is at, I did originally spec it as a 220 ohm a 10k and then 220 ohm, but then when I did the maths on it, I worked out that it really wants to be a 68 ohm resistor. I'm still working at 5 volts, and this board is mostly 3.3 volts. So I have these resistors, which are 68 ohm, or supposed to be 68 ohm. So I'll just try and get one out. Turn that around. That's, to me, reads 680. I'm just going to put a multimeter on that and see what I get. To me, that looks like it's a little bit too high a value. Now, a little while back, I actually bought a set of tweezers for my multimeter, and they might actually be ideal for this job. it is 68.9 ohms, so it is the correct value. So I'll put those away. I got quite a lot of these resistors. Sometimes it's cheaper to buy them in bulk. Right, so the next one I'm pulling out is 10K. I've got a heap of 10K resistors, and there's a heap of 10K resistors to be installed. So up around the level shifter, I'm just going to change the tilt on this microscope, try and get the light out of the reflection from the inbuilt light. So according to the schematic, 5, 6, 7 and 8 are all 10K resistors. Now that I've got them in roughly the right place, I'll straighten them up. Okay, where else have I got 10K? So R9 is a 10K. R10 is also a 10K. Right, so R 27, 28, 29, 30 and 31, 32, 33 and 34 are also all 10K. That looks pretty good. And the next 10Ks are R35 and R36. And they're located around the MPR121. And there's the two of those. That's all the 10K on that part of the board. And there's no 10K on the other board, so let us move on to our next size. So we have 1K, and there's not many of those on the board. So there's a 1K R3 located up by the IDE EEPROM. So that's the IDE EEPROM, and R3 is our 1K resistor. Next on the list is two 20 ohm resistors. So there's a heap of those, and they're all around the PCA 9685, starting at R11 and going down to R26. $16 of them to be precise. So if you're not familiar with surface mount resistors, they do have a numbering scheme on them. So this 220 ohm resistor, you read the first two digits as digits within your resistor, and the last digit is the number of zeros following. So 221 would be a 220 ohm because there's only one zero following behind. A 1K resistor would be a 10, and a 2 because there's 2 more zeros to follow. And a 10k resistor would be 103. I am trying to orientate these resistors a little bit so it's easier to see them under the microscope when you're trying to read the numbers. I got that one up on back to front. Doesn't really matter. Resistors are not a polarized device, but I am trying to make it so it's easier to read it. Of course, these are easy for a machine to do pick and place with a very small suction head. Okay, I think that's all of them. Just running around the circuit board at the moment, looking for where else there are these 220 ohm resistors, and I think that's it. So that leaves us with 3.9k. And there's 2 of those, R1 and R2. Okay, so that's all of the small resistors done. I'm just having a look over the board to make sure that that is all the small resistors. Everything else is capacitors. So we have 100 nanofarad capacitors, and they're pretty much everywhere. So C1, which is just below R1, is the first of our little capacitors. Now the problem with these capacitors is they don't have markings on them. So down at our inertial measurement unit, we have a C2, C3, C4, and C2 is a 100 nanofarad, C3 is a 100 nanofarad, and C4 is a 2.2. So we'll put 2 in down there. Now there's 2 around the NPR 121. C8 and C9, and C10 is also a 100 nanofarad. The 100 nanofarad capacitors around all these chips are mostly used across the supply for noise suppression. They get rid of high frequency noise generated by the chips themselves. And C5 under the PCA 9685. Now in around the 280S 1115s, C6 and C7 100 nanofarad. Checking on the other half, C11, C12, C13, C14, C15, C16, C17, C18 are all 100 nanofarad. I think that's all the capacitors that are surface mounted that I need to worry about. Alright, so we have two transistors, and those two transistors are used for the level shifters. So it's Q1 and Q2. Alright, let's start looking at chips. So the biggest chip on here is the PCA 9685. Now pin 1 for this is located down on the lower side of the board. I think that's pretty right. Next chip I'll do is the Ampere 6050. Oh, I missed a capacitor. I'll have to find that in a minute. That capacitor is a 2.2 nanofarad. So I'll have to find that in a minute and put that on. That dot is going to be the bottom right, which I can see bottom right there. So let's put him down. 2.2 nanofarad capacitor. I've just found them. There's only one in use here. That's got him. Now this one's going to be fun because it's so small. And that's the MPR 121. So the mark is on the bottom left of the chip, but my index mark is the top right, so I'm going to have to rotate this chip around. So U4 and U5 are the ADS 1115s. These ones are a little bit easier to identify the orientation. Now this is the IDEE prom. So the IDEE prom is something I've still got to write the code for, but it tells the Raspberry Pi during boot what this is. And it's got the index top left, like so. And that only really leaves two chips left to put in, or two sets of chips to put in. We've got the, I just bumped the camera. In this case it's a microscope. The PCF 8574. And its index mark is bottom left. You know what I haven't put in? That's the LED. Now this is a blue LED just so it stands out. I think it goes the other way around. Yeah, maybe not. It's very hard to tell with that one. Oh, there's a green light on it. Right, so the INA 219s, 8 of these to go on, all over on the other side of the board, starting with U8 through to U15. And the index is the top right hand side. And to make life easy for me, they're all orientated the same way. Need to get some more of these chips in. I've only got enough for maybe one more board left. Now I've got 0.1 ohm resistors, which will do for testing, but ideally what I really need are 0.005 ohm resistors. So I thought 0.1 would be enough, you know, relatively low resistance, but what I've worked out is we're looking for a particular voltage drop across them for a given current. So ideally I'd like 14 milliamp as a maximum voltage drop across our resistor, and if we go with 0.005 we get close to that with 3 to 5 amps of current. But since I've only got 0.1 ohm resistors here instead of 0.005s, I'm going to put them in for now, and I can always change them out later if I need to. There's a little resistor on there. Must be one I dropped earlier. I wonder what size he is. 220 ohms. So these 0.1 ohm resistors are a 1 watt resistor, and that's part of my problem with this size resistor. At 1 watt, you're going to hit that at less than 3 amps for 0.1 ohms, which is a little bit of a problem for me as well. So I will have to change those out when I get the smaller size resistors. So I think that's everything on the board, just looking over it all. So the next trick with this is to set up the hot plate and get it nice and toasty. So I'll do that and come back. Okay, so my hot plate is pretty much up to temperature. I set it for 165 degrees C. The melt point on this solder is supposed to be 138. So we'll see how accurate that is. I haven't actually tried it this particular solder before, so here goes nothing. It's actually looking pretty good. So let that cool down a bit and make sure all our parts stuck. And then I can go through the long process of testing the board out to make sure that there's no issues, no shorts, fixing any problems that might be there, and I've already found my first problem, but I can fix that with hot air. So let me just move this to where you can see it. So you can see that one's misaligned. It's not lined up with any of the solder pads, so I don't think that chip's taken at all. It is there, but I think pretty much every joint on that's going to be shorted. So that one's going to need a bit of a closer inspection. That looks like it's taken very well, that chip. That one's misaligned, so I'm going to have to redo him. U4 looks pretty good, and so does U5. And I'll try and rotate this around so we can get to the MPU 6050. Well, that looks pretty good. There might be a smidge too much solder on that. And a couple of my 100k or 0.1 ohm resistors, sorry, don't look all that fabulous on here. So when we look at this, it's this one here, this one, both need to be reorientated slowly, so I'll use hot air for those. All those capacitors look pretty good. These all look pretty good at this stage, but I am going to have to redo that one because he's misaligned with his pads pretty badly. Even the little one up here looks pretty good, so I've got to realign that one. I wonder if I'm better off doing that with the hot plate. That looks pretty good. That's better. Yeah, that's looking a lot better. I think that's going to work well. I might have to do a bit of cleanup around the MPU 6050, but I think I'll use hot air for that. It's the only one that's maybe a bit dodgy, and that resistor's probably a bit on the crooked side now. But they're easy enough to fix up. I'll do them off camera though, and I'll do a heap of testing and make sure everything's all right. So when I've finished doing the testing, I'll come back and show you exactly how all this is supposed to work. To see that video, don't forget to click on like, subscribe, and ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to help the channel further, I do have a Patreon account, and you can join my VIP patron Go Lucky, my All Access patron Jeff Jerd, my Builder patrons Al Morales 45, Andrew Cardone, Airgar69, and Stefan Paps in helping to support the channel. I also now have YouTube membership, so you can join my YouTube channel in that button down the bottom right. If you've got any questions, don't forget to leave a comment down below or drop into my Discord channel. There'll be a link in the description, and we'll do our best to answer your questions. And we'll see you in the next video.